And it all starts kind of with NCR, National Cash Register Company. Colonel Edward A. Deeds, this is the NCR probably in the 1930s, some point. Large campus here. There's the Montgomery County Fairgrounds right there, if you're familiar with that Main Street going right through here. Colonel Deeds was the president of NCR at the time in the 1930s. And if you knew anything about NCR registers and accounting machines, they were all mechanical, just gears and springs and things like that. And so with this kind of, as we kind of understood vacuum tubes and how they could be used electronically, things like that, Colonel Deeds thought it'd be a good idea to see if NCR could move away from mechanical registers into electronic registers. And so he hired a young man in 1938, he's 35 years old, Joe Desch. Joe Desch is a native Daytonian. He grew up in the Edgemont area of Dayton, just across the river from where NCR was, and he was all into early radio. He would order supplies from places like in Chicago. In fact, he ordered so many supplies from one company, a representative had to come down here just to see who he was, not knowing he was a young high school kid. He'd blow his own vacuum tubes, learn how to do glass blowing so he could make his own vacuum tubes. He got really heavily into electronics, and then he went to the University of Dayton and studied electronics there. After he left that, he worked at various places in the Dayton area. He was last, I believe, working at Frigidaire, when Colonel Deeds thought, Joe, you'd probably be perfect to head up a new electronics research lab I want to set up to work on, electronic technology within our machines, our cash registers and our counting machines and things like that. So he came on board and he set up the electronics lab. Well, also, roughly around the same time, of course, things were heating up in Europe and the like. And NCR, through kind of Colonel Deeds' kind of contacts around, he had relationships with the people at MIT, and one of them, Vannevar Bush, some of you might recognize that name, who later kind of pretty much got the United States and worked on the whole Manhattan Project and was kind of headed that up to a degree. Edward Deeds knew Vannevar Bush and his work at MIT, and of course, Vannevar Bush being in charge of the National Defense Research Committee, he would kind of give NCR some work to do. So some of these early kind of contracts, the work for the U.S. Navy and the U.S. military on electronics, NCR did a lot of that work. And of course, Joe Desch, being the head of the Electronics Research Lab, he kind of took on some of that work. And so they got to know the quality of what kind of work he would do. So one job that Joe Desch did for the National Defense Research Committee was to develop a high-speed electronic counters. And he didn't know why he was doing it, he just knew that he had to do it. And so then when he was finished, it was shipped up to the University of Chicago. And that high-speed counter was used in the Manhattan Project to help to develop the atomic bomb. That's Joe Desch in his lab with all his glass-blown tubes, hand-blown tubes right there. His lab was in Building 10 of the NCR campus. Of course, World War II breaks out. And the U-boats, especially during that time, were wreaking havoc upon Allied shipping. Thousands of ships were being sunk, tens of thousands of men lost their lives, and it was really it was horrible. This is there's been various numbers I've seen about how many ships were actually sunk or lost and things like that during the Atlantic, the Battle of the Atlantic. But this is one chart, gives you here, leading up to 42, and then after 42, it starts dropping off again. And that's, I wonder why, as this gentleman here says, and that's because of the work of Joe Desch. Okay, so the Battle of the Atlantic is raging and things like that. Now, the Germans were using a code-generating machine called the Enigma. And the Enigma was used by all branches of the German military. Okay, so the Army and the Luftwaffe and the Navy used them. Okay, but it was particularly problematic was how the Navy was using it because, again, it was wreaking such havoc upon Allied shipping during that time. So here, this is actually some Army gentlemen working on an Enigma machine right here. And that's how they would send top secret messages back and forth between the ships out in sea, the submarines and things like that, to the command in Germany. So the Enigma goes all the way back in the 1920s. This gentleman here, Arthur Scherbius, developed the Enigma machine as maybe a way for businesses to send secured messages back and forth. Well, the Germans, the military, kind of caught wind of this, and they pretty much commandeered the whole thing, basically, and started using it for military purposes. So by the late 1920s, they were starting to use it within, I believe, just in the Army, and then they expanded to the other branches. Well, the Polish Cipher Bureau in the 1930s, they kind of knew what was going on, and they were able to kind of replicate one of the machines, and they worked on trying to see if they could crack these codes. Well, they did that throughout the 30s, but of course we all know what happened in 1939, right? Germany invades Poland. Well, as everything was leading up to that invasion, the Polish, who also were kind of in contact with the British, they pretty much said, they gave all their work to the Brits to say, hey, you know, you guys need to figure this stuff out. Because the French and British were already aware of the Enigma by that time. They just didn't have the resources, the know-how to figure out what it really meant. So they sent it off to the British government. And so that's where Bletchley Park, and the Government Code and Cipher School, comes in with Alan Turing. And of course, you might have all seen that movie that came out not too long ago, all about him and that work. And again, it was used by all the branches of the military. So basically, it's a hugely complicated machine. And I'm going to try to explain how this thing works as best as I can. About every day, or about every month or so, every day, all the submarines and ships out there, the German submarines, are given these setting sheets that would tell you how to set this thing up. And there's pretty much about 4 different components of it. You have the keyboard here, you have these rotors up here, you got what are called the Stecker board down here, and then the light panel up here. And based on these settings, it tell you, you can set this all up, and so that when you push a key, it'll generate a random number random letter that would correspond to that, but that would be different every day. Okay, so the key codes that they would send out would change every day. And so therefore you would have a whole different set of possible combinations of the letter substitution that these letters could possibly stand for. All right, and there's other things that make it even worse here I'll get into in a little bit. So here you have this, I don't know if you can see it back there, there's Roman numerals 1, 2, and 5. I'm showing you right up here. Those are for the rotors that you pick. You'd have a box of rotors, each one wired differently. Every letter wired differently than the next letter to the numbers and things. And so that would tell you which rotors you would take and in the order you put them inside the Enigma. Then the next thing, you have the Stecker board. And if I go back here, for those in the back, the Stecker settings, okay, those are letter combinations in front of the board. And you can plug into, I think, as many as 13 different pairings. And that would kind of, as the code is being generated, kind of like transpose letters to other letters, okay? And then you'd have your the key codes, the message keys up here, that would tell you how to set the rotors so that it would generate these random letters. Okay, so how it worked? You'd set up everything, get everything plugged in. So this is a schematic here. You have the battery up here that would generate, of course, the charge throughout it all. Number 2 is where you push the key down. So say you want A, because that's the first letter of your sentence or whatever. Push down A. The electric charge goes down to the Stecker board, goes through the A thing here, travels up, goes into the first rotor. And then, based on how these are turned, it'll take a certain path through those rotors. So it'll take maybe a little zigzag path through the rotors. It'll come to what's called the reflector, number 6. And that basically sends the charge back through the rotors on a different path. Okay, so based on how you have them all set up, it would come out and then it would come out back out the rotors here, then travel down to the Stecker board, and where you have the Steckers all plugged in, that would again flip that all over the place. It would just flip it to a different letter. And so by the time it came out, it would pop up and the light D would light up. Okay, so you knew that D stood for A. But if I hit the A second, so what happens though, every time you push the button, the rotors will also move up a step. And so if I push A again, that A would not come out as D on my light board, it may come out as Z. So A would not transpose to the same letter every time. Okay, so that made it all difficult. Very, very complicated. So basically, they would have the selection sheet. They would set up, all people with the Enigmas would set up that configuration for that day. And again, it changes every day. And then if they had to send a message, the command would kind of start, they'd type out the message on the Enigma machine, and they would write down all the letters and how they lit up on the light board. And then they use Morse code to transmit all that. Okay? Now the message key would be like the first several letters of it right there. About the first 6 letters. That would tell the receiver on how to set up their machine, because they had to set it up differently for the message that they actually got. So they know the first 3 letters based on the base settings, but then the sender would also send a different key saying, okay, now set your machine to this. So then they can set their machines. Very, very, like I said, very complicated. And they block them up into groups of 5 like this, so it's harder to tell where words began and ended. But one thing they did do is they would usually use an X to separate words, but still, it looks just like a bunch of gibberish. So how complicated was the Enigma machine? How many possible variations could this thing create based on the changes of all these systems in it? Well, the 3-rotor, which is what they were first using when the war started, had about 10 to 114th power number of ciphering possibilities. Okay, if you didn't know anything about how the thing was set up and how it was configured or anything like that, that's how many possibilities you would have to go through in order to try to crack that code. All right, it gets worse with the 4-rotor, which I'll get to. So that's where Turing comes in. Okay, they need to break this code. So Turing, a brilliant mathematician, devises the first bomb. They call it a B-O-M-B-E, bomba. That's a Polish word, but it's pronounced bomb. No one knows where that comes from. Whether it's like some say maybe the ticking of the machine makes it sound like a bomb, but there's also a Polish dessert, like an ice cream dessert called the bomba, that was felt that maybe the early scientists in Poland who were working on this kind of liked, so they just called it that. So it just kind of carried over. But each one of these, so you have 3 rows of rotors right here, and 3 banks of those rotors. Each kind of column of those rotors is supposed to replicate an Enigma machine's rotors. So this can crunch up to how many, you do the math, different Enigma machines. You can simulate that many different Enigma machines to see if it can run through all these different possibilities to see if it can run across a hit that will tell them, to help them, of course, then break the code. So they did that at Bletchley Park, okay, and it worked. They were able to crack the codes. And so how they kind of knew some of how the Enigmas worked is that they were actually able to capture through submarines. They captured submarines, and they got Enigmas out of the machine, the submarines, and also the setting sheets, all the code books and things like that. And so they were able to use that then for a little while, because once the code books, they're only good for a little while, but still they could use them for a little while. But they got them from U-boats and especially weather ships. That's what they really hit first, because they knew the Germans probably wouldn't, suspect hopefully much. And the Germans were kind of arrogant, and they thought that none of this was crackable or anything like that. So even when they were starting to lose the war, they still couldn't believe that anyone could have cracked their codes, but they did. But they were able to get all this, and so that's how they were able to figure out some of these message keys that were critical to help you understand how the rotor should be set up. Once you knew how the rotors were set up, you could much more easily, vastly reduce the number of possibilities of the codes that you can generate. So if they didn't have those pass keys, they could use what they called cribs. It's a section of the plain text that was thought to correspond to the ciphertext. And this was just all guesswork, but educated guesswork about what plain text could match up with this. And how they sometimes could figure that out is they were familiar with the German military jargon and the communication habits of various operators. So they would use certain salutations sometimes, even like Heil Hitler or something like that. They would start to recognize what that kind of looked like or possibly could be in the messages. Sometimes some of them would use girlfriend's initials as the key code thing. So they'd fall into really bad habits of, just entering the same key code every time. And so, hello, we can figure that one out. So the initials of the master key for the rotor start position. The same message sometimes was sent twice in 2 different codes, by accident or on purpose. Usually by accident. The people who were listening in on the radios could kind of recognize standardized messages, phrases, especially from weather ships. Some weather ships would always report in at a certain time, and they always kind of start the same phrasing, and so they kind of recognized that. Submerged U-boats would sometimes surface and they radioed back to command for the messages they missed while they were down, so those messages were repeated. Again, even if it's a different code, you still recognize the pattern. Or sometimes messages were sent as a result of military action. So sometimes even the British would kind of attack just to see what messages that attack could generate from then. Oh, we were just hit by da-da. And so then they would be able to recognize where that was coming from and from who. And we're able to kind of guess and try to pair that up. You didn't have to do the moment you made that hit about what the message key was, you could crack every code that was sent that day. So you only had to get one. And so however you could do that, you just had to get that one hit. Now, some of the things with the Enigma, like I said, the Enigma that you had to understand is that the rotors moved with each keystroke. A letter type twice, actually enciphered to 2 different letters. They knew that a letter cannot encrypt to itself. So if they lined up what they thought the plain text was to the code, and those M's lined up, they knew, okay, that's no. So they can eliminate that possibility when they entered it into Turing's bomb machine to crunch the various calculations. And of course, then they would put the X between the letters, so they would recognize when that would occur. All right, so February 1942, the Germans added a 4th wheel to the Enigma machine, which vastly increased the number of possible combinations, 10 to 145th power number of ciphering possibilities, which made the British bomb obsolete at that point. So now the race was on to figure out a new machine. And the United States tried to get information because they wanted to work on it, things like that, but the British were kind of reluctant to give up their information, partly because they felt that the European theater Atlantic was their domain. They said, kind of like through an agreement, whatever, and that the U.S. should just worry about the Pacific theater and things like that. And plus, they were kind of really worried about the information being transported back and forth and things like that would get lost, or the Germans would steal it or something like that. So it was like pulling teeth to get the British to kind of let us know what they were doing. So we kind of had to start in a lot of ways from scratch on it. So that's when the U.S. Navy approached NCR to build this new code-breaking machine to crack this new Enigma code. This is NCR on Main Street here. NCR at that time had already been doing a lot of war work. Like a lot of factories in Dayton, they turned over all the facilities over to war work. They got various Navy, this kind of way of recognizing the contributions of a company to the war effort. They would award them this E rating here. This is some women assembling fuses at NCR in 1942, and also men working on gun magazines at NCR in 1942. So they approached NCR and Joe Desch and say, hey, could you design a new machine for us to do this? And I guess he said yes, because he had no choice. So he moved his facility from his Building 10 to Building 26. This is Building 26. It was built in the late 30s as the night school for NCR. It was located on the corner of Stewart and Patterson Boulevard. And they kind of called it, what his lab in there was, the U.S. Naval Computing Machine Laboratory. So here's the NCR campus, the fairgrounds. Building 26 is right down there. Okay, that's what it looked like at that time. Of course, it's no longer there. I'll get into that a little later. So here's Joe Desch with the Navy command here that was in charge of watching him. This is Lieutenant Commander Meter, who pretty much lived with Joe Desch, and I'll tell you why in a bit, and watched his every move. And some of the WAVES, the Women Accepted for Voluntary Emergency Service, the WAVES who helped to build these machines, even though they didn't know that was what they were building, because it was very top secret, ultra top secret, as they said. And so the WAVES, they came into Dayton in April of 1943, So here's the front page, Dayton Herald, wave contingent to begin training here. No one was told why the waves were there, really, because it's so top secret. So in the paper, it just says members of the contingent will complete a course of training at NCR in which they will learn to operate special accounting machines used by the Navy Bureau of Supply and Accounts. They're just here for training, right? Okay, no big deal. No one ever questioned it. So it just kind of went on. So this is Sugar Camp. As it looked, they lived at Sugar Camp, which was the training grounds for NCR sales staff. It was started in the late 1890s by John Patterson, the founder of NCR, to train his sales staff from around the United States. And so they come here to Sugar Camp. Sugar Camp is kind of at the intersection of Shantz Avenue and Far Hills Avenue. That intersection is right up here. Shantz is right here. Of course, none of this exists anymore. We have one of the last cabins at Carillon Historical Park now. So the Waves lived there. Up to about 600 Waves lived there over the course of the couple of years that they worked on this, about 300 at any one time, working round the clock, 3 shifts a day, trying to build these things. Some of the kind of look at the life that they had. They had all the facilities. There was a social kind of reception hall there, dining facility, swimming pool, all sorts of things to make life as pleasant as possible for the Waves as they were working there. And these are the Waves marching down out of Sugar Camp to go to Building 26. They marched there, all down there, down Shantz to down Main Street, down to Building 26. They said they sing songs as they're marching and things like that. Again, not knowing at all what they're building. They just knew that they had to build things. They had to solder them together. This is the soldering room here, one of the rooms where they're working on soldering. All the rooms were designated for certain Waves to be in only in those rooms. If your name, there's armed guards standing outside all these doors, and if your name was not on a door and you tried to go in there, they would horse collar you and pull you right back out. And they couldn't even talk about what they were doing, not even among themselves, about in their individual rooms with each other. It was just so top secret. And they could, be tried on treason charges technically if they did speak about this kind of work they were doing. But still, they didn't know what they were doing. They were just soldering these components together as they were told. So they work in there. This is one of the actual Joe Desch machine. They would solder these little points on here onto what are called commutators, or just rotors, that would kind of spin at high rates of speed to help figure out if they can make a hint about what the the code was for that day. So this is a completed code-breaking machine. It's 10 feet long, 2 feet wide, and 7 feet tall. Weighed 2 tons, and your cell phone probably has 1,000 times more computing power in it than this thing did. Okay, but it was a pretty amazing feat for its time. Now, this whole thing was so top secret. Joe Desch, like I said, he had Lieutenant Commander Meter, the guy in charge of it here, living with him, watching him day and night. If he couldn't do it, he had people would follow Joe, unmarked cars, just making sure he used German by nationality. So they had to research his whole background, figure out who his relatives were, and I guess my understanding is that they found relatives of his living in Germany that he didn't even know about. He was only allowed to have very limited visits with his mother. And probably, people were sitting in the room with him if he was with his mother, listening to him. And they would put a lot of pressure on him. Constantly, Lieutenant Commander Meter was telling him that, Joe, men are dying. Men are dying. If you don't get this thing going, men are going to keep dying. And basically, he made it feel like it was his fault if you don't get this thing figured out quickly. Okay? And they were quite literally. And so whatever pressure he could put on him to keep moving. So Joe Desch and his team worked 7 days a week, sometimes 14 hours a day, to try to make this machine happen. And so this is what they did. Now, a lot of it was thanks to this thing called the Thiotron tube. Joe Desch didn't invent it, but he made at least little small ones, and he invented the Thiotron chassis that was used to work on the code-breaking thing. Because these things would count, they were high-speed circuits, basically. And so when the wheels on this thing were spinning, this thing would have kind of an electronic memory in it. So it would count the number of revolutions as these things are going. And some of these rotors would spin at 1,800 RPM. 1,800 rounds per minute. But when they found a potential hit as they were spinning, they didn't just stop right away. They would go several revolutions past the hit before they actually stopped. But because these things had a little memory in them, they could tell, you see where it made that hit. So you just reverse it back it up until you see where that Thyotron was showing you that hit was. And then you can start it back up again. This thing was able to calculate and basically worked about 30 times faster than the British bomb did. So it was much faster. And it was very accurate. So it could crunch the numbers of the letters, combination things of a 4-rotor machine in about 20 minutes. And each one of these rows here, again, there's like 8 of them right here, they're all simulate a 4-rotor Enigma machine. So you put what you think is, up here on these dials, you put up there what you think the possible combination, the code combination and the substitution, letter substitution, all in the plain text of what you think the message may be. And then these things will start spinning around. And if the circuits all line up to each other, it'll say this is a potential hit. This is very, very potentially what we're looking for. And then, it always kind of result in about 3 or 4 possibilities. So within a matter of a couple hours, which seems like a long time to us now, but it was much faster than the British bomb. But within a couple hours, usually, they would have the code messages for that day figured out. And so for the rest of that day, they knew they can read all the German military and the Navy's messages they were sending to all their submarines. So they knew where the wolf packs, as they called them, would be. So they could either go out and attack them, or they can tell the convoys of cargo ships to kind of where to avoid. And so that's why in that one number you saw the number of ships sinking and going down after 1943.
42 to 43.
Mm-hmm. So they started the work really, they started in about March 1942 working on this. Waves came April. By August, they were shipping the completed bomb code-breaking machines to Washington, D.C. to start that work. So in August 1943, they were sent out to Naval Communications Annex near Washington, D.C. Some of the same waves that worked on building them were assigned to this facility to operate them. And about 121 of them were built for the work. And again, they vastly shortened the length of the war. We were able to tax these subs. We knew where they were. Again, here you can see how the numbers dropped after 1942. Okay, because we cut off basically a lot of their safety in numbers in terms of being able to ship and get supplies themselves, so they kept running out of supplies now, the German military. And the only Joe Desch designed bomb machine exists at the National Cryptological Museum in Washington, D.C. This is it right here. They stopped producing them in September 1944. Joe Desch, he died in 1987, but in 1947, Harry Truman presented him with the Medal of Merit, which was the highest, at that time, was the highest civilian honor you could receive. But in the citation for it, nothing was mentioned about the project at all. It's just that, thanks for your contributions. Joe Desch could not talk about it at all until the day he died. Not a word. His daughter didn't even know basically what her dad did. Until much later, she's going through some of the stuff and found some very interesting things in it. Because the whole project was not declassified until 50 years after the war. So this is Debbie Desch Anderson, Joe's daughter. Medal of Merit. Oh, and I should say this, that after he completed this, he did other work for the U.S. Navy and the military, especially in the Pacific Front. Again, a lot of pressure was put on him to work on the various projects on that as well. And apparently after all was said and done, he did have a bit of a nervous breakdown, if you could probably understand that, though. This is about a 2001 reunion of the Waves at Sugar Camp. But 1995, the group that was there, of the Waves and other military personnel that worked on it, that's when they finally learned about the project and the significance of the work they did on it. because no one knew. They kind of suspected here and there, but they didn't know until that long after. So in the 1960s, NCR added kind of an outside facade to the building. I don't know if any of you remember that building on the corner of Stewart and Patterson. But it was that building right there. The old Building 26 was in the back part of it right here. This is Debbie standing in front of it. But NCR, eventually they sold the property to the University of Dayton in the early 2000s. But before that, this plaque was erected in front of it on a boulder, kind of talking about, commemorating it. It was put there after 1995, of course. That boulder is now at Carillon Park in front of our Sugar Camp Waves cabin that we have. But unfortunately then, there were some efforts to try to save the building, but to no avail. It was torn down in 2008. So now it's no longer there. But we do have an exhibit at the Carillon Historical Park that pays homage to the whole work there. A lot of the brick and other architectural elements from Building 26 were used in the exhibit space. We have a Waves uniform from one of the actual Waves that worked there. A couple of the doors, kind of talking about NCR's secret tunnels they had between their buildings. But then we also have an exhibit here showing you the rotor and one of the Thiotron tubes in it, and a little display case there. We also have the Waves cabin that, of course, talks about that whole story as well. It's one of the last Waves cabin that was moved from the Sugar Camp site to Dayton History in 2004.